Hey, I'm Stacey. My colleagues and I are going to be doing a series of problems, some data sufficiency, some problem solving, but all of them are from the free problem set that comes with the official GMAT starter kit at mba.com. We're going to each do some different problems, but then we're actually going to finish grand finale by showing a problem that we each did and show the different ways that we thought to solve it and how we used the whiteboard. You need two things because we're going to make you play along. So go grab yourself a timer and pull up our online whiteboard.
Hi, my name is Daniel. I'm going to be using my trackpad. All right, now pause this screen, set a timer for 2 minutes, and come back and reconvene once you've taken a crack at it. All right, here's my solution. Here we go. Okay, if a is a positive integer and if the units digit, okay, this problem is about units digits. If the units digit of a squared is 9. All right, so it could be 3, but it's probably not going to be 3 because they wouldn't present the information that way if it were. But let's just see what else it could be. So units digit have a pattern. Every digit has 1. So 1 is 1, 2 is 4, 3 is 9 when you square it, 4 is 16, so 6 when you square it, 5 is always 5, 6 is always 6, 749 is 9. There's our other 9. Let's just check the others real quick. 8 is 4, right? 64, yep. And 9 is 81, so that's 1. I skipped 0, but 0 is always 0. Okay, so it could be A could be end in a 7 or end in a 3. And the units digit of a plus 1 squared is 4. Okay, right, yeah. So here this tells us it because if it ended in a 3, 3 plus 1 is 4, squared would be 6, so that can't be right. So yeah, just as I thought, it is the 7. So 7 plus 1 squared, 8 squared is 64. Okay, cool, yep, so check on that. It ends in a 7. So the units digit of a plus 2 squared, so 7 plus 2 is 9, squared is 81, and yep, one of these answers isn't even a digit, so E definitely doesn't make any sense, but the correct answer is A. The units digit of a plus 2 squared is going to be a 1 because it ends in a 7. Cool. All right, so as you saw for that problem, some of the math, the kind of basic, what is 8 squared, I'm just doing in my head. Probably do that in my head because I know those cold, whether I was using the online whiteboard tool or not. Just made sure to track the units digit patterns, write those down, make sure I was catching them all. But other than that, this is mostly about just recognizing when the problem says units digit, it's all about the units digit. And then also kind of knowing that when they give us the units digit of a squared is 9, it's a little too simple for the GMAT to be thinking about 3 there. So I was pretty sure just right at the top it was going to be something else. Once I found that, figured out 7 was the other option, the rest of the problem unfolded pretty seamlessly.
Okay, you ready to try this? I'm going to be using my finger on my trackpad. You pause me and go try it and start me up again. And you. The answers are interesting. Okay. I like decimals, so I'm translating these. The answers are actually decently far apart, which means I can estimate because that's really ugly. 2.3. It's basically 1/2. Plus 1 is 3/2. I don't like fractions. And that's okay. So 1 over 1.5 is between 1 over 1 and 1 over 2, which is 0.5. So it's sort of like 0.75. It's not quite halfway in between. I'll explain in a sec. It's really like 0.7-ish. Yeah, okay. And that's it. It's got to be. That's the only answer that makes sense. Okay. Where do we start with this one? The first thing I thought is I think I said ew when I saw the question. That's just ugly. Why are they making me do this? I'm actually glad on this one that I had the whiteboard because I didn't have to fully then, if I had to do this on the yellow pad, I would have had to fully copy it down and like literally proof it because it's so complex. So this was a little bit easier to do being able to look at it the whole time. I don't want to do that if I don't have to. And the answers, the first thing I noticed was that these two are greater than 1 and these 3 are less than 1. So if nothing else, I could probably at least estimate whether it's greater than 1 or less than 1 and make a guess, even if I somehow couldn't do the math. Even within that, like this is less than half, this is greater than half, this is almost 1. So even these, the gradations are enough that I can do some light estimating here, and I'd rather do that. 2 1/3 is basically 2.3833. I estimated that down. This is the one kind of big estimate that I made, big-ish, down to 1/2, add 1 to get 3/2. I don't, as I mentioned, like fractions as much as I like decimals, so I did that. And then this little trick that I used here is something that I like to use to play with. So basically 1/1.5 is between 1/2 and 1/1. Basically 1.5 is between these 1 and 2 denominators. So that means that this fraction is also between the two, between 0.5 and 1. And because I've played with this before, because I like to use this as an estimation method for fractions, I know that even though 1.5 is exactly halfway between 1 and 2, the decimal that comes out of that is not exactly halfway between 1 and 2, so it's not 0.75. It skews. It's almost like a weighted average, kind of. That's the way my brain thinks of it, where it tilts one way or the other. And in this case, it tilts towards, or in general, these tilt towards the smaller end, basically. So this 1.5 is not 0.75. It's something a little bit smaller than 1.75. So I guesstimated 0.7, and that was right there in my answer traces. This is really the only one that's close. Oh, and I did notice one other thing as I was talking about that. As I said, I don't like fractions. I prefer typically doing stuff in decimal or percent form, but I might have saved myself like 4 seconds if I had noticed that the math that's going on for this stage right here is 1 over this fraction. And when you have 1 over a fraction, all that means is just take the reciprocal of the fraction that's on the bottom. And so from there, I could have gone straight to 2/3. And then again, that's the closest thing. The only thing that makes sense is the 0.7. Honestly, I probably still wouldn't do that, even if I saw this on the real test. Like I said, my brain just goes here, and that's where it's most comfortable. If I see some kind of a shortcut that I didn't think of initially that's going to save me significant time or significant brain energy, then yeah, I'm going to go ahead and learn that thing and make it my new normal so that I always do it that way and save that time. In this case, we're talking about a few seconds. At that point, it's worth it to me to spend the few seconds to keep my brain in a mode that's comfortable for it, because that's going to help me as I go through the test, just to not use up too much brain energy as I go, basically. And I think that's it. So yeah, good luck.
Hi, I'm Zach, and I'll be using a trackpad. All right, go ahead, pause the video here and give yourself 2 minutes to give this a try. All right, and we'll dive in. Does the integer k have a factor p such that 1 is less than p is less than k? Okay, so what is that asking? Basically, it's asking, does k have any factors between 1 and itself? Which is basically asking, is k prime? It's the inverse of that, but if k is prime, there won't be a number p in between. Otherwise, there will be. So that's probably how I'd rephrase it. Let's set up our AD over BCE. Statement 1, k is larger than 4 factorial. So essentially, that's just telling us k is a large number. But there's a lot of numbers in that range. Some are prime, some are not prime. So 1 on its own is not enough. So I would probably take out the top row. And then statement 2 is much more complicated. K is in between 13 factorial plus 2 and 13 factorial plus 13. Okay, so what's occurring to me is that gives us a range of values that k could be. On the low end, 13 factorial plus 2, all the way up to that other value. And it has to be an integer. So it's either 13 factorial plus 2, 13 factorial plus 3, etc. And I want to figure out whether or not it's prime, or whether or not I can pull a factor out. Well, in that first example, I could factor out a 2, because there's a 2 in 13 factorial and in 2. Or if it's 1 larger than that, I could factor out a 3. And you could keep doing that until we get up to that last value, and then I could factor out a 13. So no matter what the value of k is in that range, I'm able to factor something out, which means there is always going to be a value for p. So that means statement 2 is enough on its own. So I would say my answer is B here. Okay, so that's what I would do for this problem. A few thoughts looking back on it. In terms of what I write down, I really like to use the text tool to kind of capture my thoughts, particularly if I'm rephrasing something in a conceptual way, like is k prime? Just writing that out in words to me is really helpful on this problem. And that's a good place to do the text tool. In terms of thinking through like the different consequences of statement 2, I might write those out. I might be doing that in my head, but I do think utilizing the keyboard and the text tool when you can is great. Just a few other things I would mention on this problem is statement 1 is not giving us any extra information that statement 2 is not. Statement 2 already tells us it's a large number, so we're not any better off with 1. So if I had to guess on this problem, which for some people might be a good call, I would also feel comfortable taking out C, because we're no better off with statement 1 than we are with statement 2. And perhaps we would guess between B and E, and that would be okay. Those are my thoughts. Good luck with studying.
Okay, so you've seen us each do our own problem. Now you get to watch us do the same problem. You'll get to see the similarities and differences in terms of how we thought to solve this thing and how we use the whiteboard. What else? Oh, you should try the problem. You try the problem first, and then watch us.
Okay, so let's see. Data sufficiency. If R and S are positive integers, is R over S an integer? Okay, let me just think about what that means for a second. Is R over S an integer? So is S a factor of R? I can just rephrase that. Is S a factor of R? That's my question. They're positive integers. Okay. All right. Statement 1. Every factor of S is also a factor of R. Okay, well, S is a factor of S, so if S is a factor of R, then S is a factor of R. That was my question. Don't need to write anything for that. That one's just straight to the rephrase. All right, statement 2 here. So we're down to A and D on our grid. All right. Every prime factor of S is also a prime factor. Prime factors. Every prime factor of S is also a prime factor of R. Okay, well, the situation we were just talking about, that would give us a yes. So can we get a no here? The prime factor of S is also a prime factor of R. So yeah, if they have the same prime factors, but R has more of them. So let's say that R equals 4 and S equals 8. Then they both only have 2 as prime factors. So we satisfy the statement every prime factor of S is also a prime factor of R, but S is not a factor of R. R over S is not an integer. And we could just flip this and use these same exact cases, but flip and get the other answer to get our yes there. So statement 2 not sufficient, statement 1 is sufficient. And therefore, the answer to this question is A. All right, that's a pretty tricky question. I think largely conceptual. Anytime you have one thing over another equaling an integer, you want to think about that as is the denominator a factor of the numerator. And it's a little tricky here to think about the different factors versus prime factors. So as you can see, I'm approaching this question as I do most number properties questions relatively conceptually. I think for the second statement, which is maybe a little tougher to deal with, it's helpful to give a quick test case. But you know, for me, in terms of the whiteboard, if this were on paper, maybe I'd write a little factor tree of what the prime factors of R and the prime factors of S were or are. But instead here, it just shows to write out R and S And I made sure to choose really simple numbers that are going to have a prime factorization of just 2. So I wasn't really missing anything by not writing that down.
R and S are positive integers is, oh, I recognize that. So if R over S is an integer, what that basically means is S goes away. It's really S is a factor of R, or is it? And statement 1 says what I just said. I'm not even going to write down BCE. Ooh, how does it change when it's a prime factor? Okay, that's still going to be my yes case. Okay. But if we change this, that's still a yes case, but there's the no case. Okay, so correct answer in this one is A. That was a little more intricate than it looked. One thing I'm noticing is like how messy my scratch work is. It's actually totally fine. I'm going to remember what it said. It doesn't matter for the 2 minutes that I'm in this problem. It doesn't matter that it needs to be perfectly perfect and exact as long as you know what's going on. My scratch paper is often messy even when I'm trying to write with a pen. This is especially messy. It probably would have been better for me to grab the text tool for that piece of it. I did jot down that they told me that R and S were positive integers. I didn't look back at it once I wrote it down, but I always write that stuff down because it makes me slow down long enough to cement in my brain that they told me this, because they don't give us that info on the quant section unless there's a reason. So I want to make sure I remember it. And this is the bit where my hard work paid off in advance. Whenever they tell us that one integer is a factor of another integer, like this is actually my shorthand for writing it down, that the one over the other becomes an integer, because it helps me to think about it in the sense of like the factor part of it, the S part of it, needs to completely divide out in order for this whole thing to turn into an integer. So I recognize that, and that was my angle into dealing with statement 1, which basically says the same thing. If every factor of S is also a factor of R, then I'm going to cancel out all of the denominator. And I'm going to be left with an integer up here. It was a little trickier to deal with statement 2. I had to think about how prime factors would change that. If I hadn't tested this out and had just had to guess, I might have just guessed that statement 2 would work too. The distinction here basically is that if I've got something that repeats, that uses multiple prime factors to get to that number, like 4 is 2 times 2, but it really just has the one prime factor, 2. So I could make R 8, in which case I am going to get an integer, 8 over 4. But I can also make R 2. They still share that prime factor of 2, and 2 over 4 is not an integer. So that was my no case to cross off answer D and get to A.
All right, let's dive in. If R and S are positive integers, is R over S an integer? Okay, so the first thing I'm thinking about is, what does that mean for R over S to be an integer? And that's really code for, is R divisible by S? Or is S a factor of R? There's a few different ways we could articulate that. Okay, so let me do AD over BCE. Statement 1, every factor of S is also a factor of R. Okay, that's just the definition of a factor. So I feel pretty comfortable out of the gate saying statement 1 is sufficient. Because for example, S is itself a factor of S. And so that's telling us that that's a factor of R. I could test values there, but I feel comfortable with kind of the definition of that as a factor. And so then statement 2, every prime factor of S is also a prime factor of R. Okay, so the way I process prime factors is to say S and R are composed of the same types of building blocks. But I don't know how many are in each. So for example, if they're composed of the same prime factors, that could mean that S and R are both built out of only 2's. S and R are just built out of 2s. But maybe R is 2 and S is 8. That obeys the statement. They're both built out of 2s, but in that case, R is not divisible by S. But we could flip those around, and maybe R is 8 and S and 2, in which case it is. So just knowing that they're built out of the same building blocks doesn't tell us about divisibility, because the denominator could have a lot more of those building blocks than the other. So that tells me statement 2 on its own is not sufficient. And so the answer is A. All right. So those are my thoughts on this problem. You'll notice I really like using the text tool. The reason I like it is I think it models what is going on in my mind. When I am doing practice problems, I often talk out loud to myself and reason my way through things. When I am teaching, I'm of course also reasoning my way through things. And often when I'm teaching, I just write out my thought process onto the board. And I find that this is essentially doing what I'm doing when I use the keyboard as well. Testing cases is kind of borderline. If it were more complex, I might actually want to do a chart to stay organized. These cases felt straightforward enough where I could just describe them using the text tool. But there would probably be a tipping point in difficulty where I might switch to using a chart. Also, I don't need to write down every single thing. So statement 1, I felt like I could evaluate that in my head. Statement 2, perhaps I might want to write out my thinking for. And so that's something I want to be flexible on. I think something that the text tool is really useful for is rephrasing the question in conceptual terms. And so is R divisible by S is a very clear rule or criteria for me. So being able to write that out is easy for me to keep coming back to. Yeah. All right, those are my thoughts. Good luck with studying.